Hello everyone, this is Sakshi and I welcome you all to my EdTech platform, Way to Learn. So today I'm going to solve some of the problems from classical mechanics. So today's topic from classical mechanics is Lagrangian dynamics. So in my last class, we saw what is Hamiltonian dynamics. And now before we start, when you have confidence, you can have a lot of fun. And when you have fun, you can do amazing things. So let's have fun and let's do amazing things. So let us see Lagrangian dynamics, and these 3 points are the important definitions to be known for a Lagrangian to set up. Okay, so we have to know the degrees of freedom. So degrees of freedom is nothing but the number of independent coordinates required to describe the system. So if you have a system like a simple pendulum, compound pendulum, Atwood's machine, so we have to find the number of independent coordinates that is required to describe the system. So it can be the length of the string, the angle, the xy axis, everything. And next is the constraint. So constraint is the limitation imposed on system. That is, if I say that the length of the string is constant in a simple pendulum, so that is a constraint. So I say that the length is constant, so I will not vary my length. So I have imposed some condition on my system. So that kind of limitation are called as constraints. And third one is the generalized coordinate. So generalized coordinate is also the coordinate required to describe the system, but these generalized coordinates are the minimum number of the independent coordinates required to describe the system. So degrees of freedom are such that there is the total number of coordinates required to describe the system, whereas generalized coordinates are those in which only if you have two coordinates and you can describe, okay, this system is simple pendulum or this system is Atwood's machine, those are generalized coordinates. And so in order to find the degrees of freedom, one can use this formula, which is given by 3n minus k. Here n is the number of particles. That is, if a simple pendulum, then we can say that a pendulum has mass m, which is one particle, so it can be 1. So it depends on the system. And k is the number of constraint equation. That is, I said that L is constant, so that is one equation, or so on. You can consider as many constraints. So next important thing is the Euler's-Lagrange equation, or we can say this as the equation of motion. So you can get directly as find the Euler's-Lagrange equation, or you will get like find the equation of motion of the system. So you have to remember this formula, which is very important, which is given as d by dt dou L by dou Q dot minus dou L by dou Q is equal to 0. And next one is the canonical momentum, which is given as PQ is equal to dou L by dou Q dot. You have to remember this. It's very important, and we already seen this formula in our last video. So this is very important for you. And the other one to know is you'll have some questions like you'll have some Lagrangian given, and you will be asked which of the quantity is conserved. That is, which of the momentum is conserved. So if I say that if only Q dot is present in the Lagrangian, I have given some Lagrangian and it has some terms like Q dot and Q. But if I give some other Lagrangian in which only Q dot is not Q dot is present and its half Q is not present. So if only Q dot is present in the Lagrangian, then we say that Q dot is a cyclic coordinate. So just remember, if only Q dot is present in the Lagrangian, then Q dot is the cyclic coordinate. It can be x dot, y dot, z dot, theta dot, anything. Okay, so only the derivative should be there and not the and the quantity should not be present. So such terms are called as cyclic coordinates, and their corresponding momentum is conserved. See, if Q dot is cyclic coordinate here, then PQ will be conserved. That is, the momentum will be conserved. So you'll get so many questions for GATE exams like this. And then in order to set up a Lagrangian, like if you have a system and they say like set up a Lagrangian, find the Lagrange's equation, then you'll have to find the degrees of freedom, like number of coordinates required, and then we have to find the generalized coordinates, that is the two important, like two or three important coordinates that is enough to uh, describe the system. And then third step is you'll have some x and y. If they have not given any information about x and y, you have to convert them in terms of generalized coordinates. And then the step 4 is your finding t and v, so that we can set up the Lagrangian as t minus v. So let us see a problem. It's actually very easy, though the theory is very vague. We'll see the problem and just understand what is it. So here is example. A particle of mass m is constrained to move in a vertical plane along a trajectory given by x is equal to a cos theta, y is equal to a sin theta, where a is constant. Find Lagrangian and also find the equation of motion. So here I consider the vertical plane to be my x-axis and my horizontal plane to be my y-axis. So I have considered ulta, but I have just considered on that basis and have done the problem. So here they have given x in terms of theta. So here our generalized coordinate will be theta. So they have been given in the generalized coordinate. So we don't have to convert anything. We have directly our x and y. Now we have to just set up the t and v for our Lagrangian. So here t will be half mx dot square plus half my dot square, and v will be mgx. Why mgx? Because y will be constant here, because I have considered y to be horizontal motion, and my constraint is that uh, the particle is constrained to move in a vertical plane. So it should move only in a vertical plane. So if you consider the vertical plane to be y-axis, then instead of x you can here put as mgy. So that is the difference over here. You can try both the ways. Both the answers will be correct. So now the Lagrangian is given as t minus v, and then to find t we need to find x dot and y dot. So I have just found x dot and y dot. Here if you do the only variable is theta. So if I do like cos theta, I get minus sin theta, and theta is a generalized coordinate and also it will be differentiated. So it is written as theta dot. Similarly, I find y dot and I'm just substituting in my t and v. Okay, then I find L is equal to t minus v. I can simplify t even more simpler. So I get my t as half ma square theta dot square. So I found my Lagrangian. So this was the Lagrangian. And next step is to find the equation of motion. So we have the Lagrangian now. And we know that the generalized coordinate here is theta dot. Okay, so next we have to find the Euler's Lagrangian equation, that is the equation of motion. So that is given as d by dt dou L by dou q dot, where q dot over here is theta dot minus dou L by dou t is equal to 0. Okay, so I have to find what is dou L by dou theta dot, and I do from given Lagrangian I get ma square theta dot, and then again differentiating I get ma square theta double dot. Okay, so I'm differentiating this with respect to time. Okay, so next again I have to find the second term, which is differentiated with respect to theta. So I get this as mga sin theta. So on substituting these in this formula, we get theta dot is minus g by a sin theta is equal to 0. So I hope you understand this, and if you get this, then this is going to be your homework problem, and this is going to be very easy because I have already given the diagram. You don't have to think, okay, what should I consider? So we can just see the diagram. You can check what is given, what are the constraints and everything. We have to set up the Lagrangian for this particle. So let us see the homework solution for my last video. So my last solution was for the Lagrangian of dynamical system in 2 dimensions. That is, I had given my Lagrangian and I had to find Hamiltonian, right? So we know the conversion formula, so I'm going to use that. And yes, here there are two variables, x and y. So my Hamiltonian will vary as px x dot plus py y dot minus L. So I hope you understand this formula. So, and I am writing their corresponding momentums, and I find those corresponding momentums px and py. From py I get x dot and then and from px I get y dot. Now my step is to find what is h. I just substitute all those, simplify, and later you have to remember that you have to find everything in terms of py, py, like in momentum, not in the variable, that is x dot y dot. Okay, so you have to find there is your h should be dependent on x, p, and t, not on x dot and t. So just keep this in mind, and I hope you have done this right. So keep watching my videos, and stay tuned for more videos, and like my videos, share my videos, subscribe my channel, and also hit the bell. So see you tomorrow. Ta-da!